Okay, it's on recording.
Yeah.
Okay. So any idea on OSI model, Kader?
I know I can hear clear.
Huh?
It's okay. I can hear clear.
Okay, voice is clear. No, I just asked any idea on OSI model?
What's that?
This one, on this one, OSI model. No
You
idea,
see,
right?
you want to record it like all?
I have turned on the recording. I'm just asking you about the topic. Are you aware about this one, the OSI model?
Yeah.
Okay. So what is OSI stands for?
So do I got it?
Sir, Idira, I have turned on the recording. I think this is recording. Okay.
Okay. Okay.
Am I clear to you? My voice is clear. Is it audible?
Yeah, I can hear you, but a little bit low.
Okay, 1 minute. Okay. Am I audible now properly?
Yep.
Is it much okay? Voice is okay now? Kader?
Yeah.
Okay. So here, OSI stands for Open System Interconnection. Okay. So let me write down here. OSI. It stands for Open System Interconnection.
So the camera, do I make like this or I make it off?
Do you want me to turn on my camera?
No, mine. No, you're
Let it be your camera, let it be.
okay.
Okay. So OSI, just a minute. Is it visible now properly?
Yeah, I can see OSI. Yep.
Yeah. So here, this is refers to Open System Interconnection. Okay. So this is a reference model of TCP/IP. This is a reference model of TCP/IP. TCP/IP stands for Transmission Control Protocol and Internet Protocol. Do you want me to write here? Do you want me to elaborate this one?
Yeah.
Okay. It stands for Transmission Control Protocol, and IP is nothing but Internet
Provider.
Protocol.
Okay, vertical. Okay.
Okay. So here, this OSI reference model, it was introduced in the first protocol was TCP/IP. The first protocol was the model which is called TCP/IP model, which was released in the year like in between 1970 and 1975. Which model is that? It is released. TCP/IP was the first model which was released. So in 1984, by keeping reference of this model, they have introduced the OSI model. Okay, in the year of 1984. So the difference between here is in TCP/IP, there are 4 to 5 layers. There are, usually we call that 4 layers. So sub layers, if I add, it comes 5 layers. Okay, TCP/IP having 4 layers, and here OSI reference model is having 7 layers. Okay, So where this, what is the necessity of introducing this OSI model? So the thing is, so here earlier, so when we have, suppose let me take, this is one organization. I just say this is belongs to hp.com. Okay, this is belongs to hp.com. And I
Okay.
just go with another organization. So this is belongs to ibm.com. ibm.com. So now I have multiple users here. Let me take this. I have multiple users. These all are the users. Okay, they all are the users. So now the thing is, I wanted to make communication between hp.com and ibm.com. I want to communicate the users of hp.com and between the ibm.com. In earlier, that is in 1960s and 1970s, the problem is, suppose if hp.com users are my pen is not working proper.
No, I can hear you well.
Yeah.
Yeah.
Okay. So here hp.com users were, suppose if this machine, okay, if this machine, if it is using with, let me take this machine, it is using with the manufacturer. So I'm talking about manufacturer. Pen is not working properly. Okay.
Okay.
So the manufacturing of this machine, if it is belongs to it, if it is manufactured by HP product, if this is a HP product, and all this all belongs to HP product. These machines all belongs to HP product. They are the manufacturers. So here
Yep.
the devices who have manufactured by IBM. Okay, these are the devices, IBM or Dell machines. Let me take Dell machines they are using. The problem is, if I want to send the data, I want to communicate from this user to this user, that is hp.com user to ibm.com user. I want to exchange the data or information between these two companies, means it was, if this is belongs to HP product, if this is belongs to Dell product, the problem is they were not able to communicate. Why? Because the manufacturing of this machine and this machine is going to follow on the different protocols or different rules it was there. So just now assume here we have how many manufacturer companies we have manufacturing product of computers. We have different manufacturing, like HP, we have Lenovo, we have Acer, we have, and also we have Mac. We have different manufacturers of a product. We have different products in the market. So that the thing is, if the users here, the users of hp.com need to use only the HP products, then only and here if I want to exchange the information between ibm.com, means here also they have to use HP products and here also they have to use the HP products. So it was not possible. Okay, so to overcome this issue, what they have thought, they thought to send some TCP/IP model was created. What they have decided, they have created some model. That means whenever the information need to exchange between two companies, the manufacturer need to follow some rules, rules means what? Some protocol. Are you able to understand, Kader?
Yeah, I'm with you. Yep.
Yeah. So they have to follow some protocols. So I can tell you in actually we have plugs, right? We have laptop plug, you have laptop adapter, you will put for charge, right?
Yep.
You have laptop adapter. You have noticed, you have which laptop you have? You have Mac.
Yep.
Other laptop do you have? Any Windows machine you have?
HP.
HP machine. So what is that adapter? That 3-pin charger, you know?
Yes.
So that is, so it comes in same size. So the 3 pins, so in the plug board, that is in the wall, the plug board where we take a connection, it all comes in the same sizes, right? It will never
Yes.
differ. 2 pins,
Yep.
2 pin we insert, 2 pin plugs we insert, 3 pin plugs we insert, or USB port we insert. It all have some standards, correct? Standard size, standard color, standard
Pin.
yeah, all that is standard. So here also same thing. What they have decided, they have decided to set some standards for the manufacturing, to set some standards for the manufacturers. Clear? Why TCP/IP model is introduced? Clear?
Yep.
Okay. So this TCP/IP model was the older version. They have reversed this or enhanced this model from 4 layers to 7 layers. So the OSI models come into the picture. Understood why OSI model is necessary?
Well done.
Yeah.
I can hear you. What do you say?
Here, the first model was TCP/IP, which was in 4 layers. This model, which they have introduced with 4 layers. So that means I wanted to tell you here, see, suppose if I have 2 machines. So here, this is a sender and here he is a receiver. Okay. So I want to exchange information from, let me assign some IP address 10.0.0.1, 192.168.1.1. So just assume this is over the internet, ISP, or over the internet. So I want to send the information from this machine to this machine. So how information? See, my information, it can be anything. It can be Word file, it can be JPG picture, it can be WMV, it can be voice, it can be anything. My information is in different format. Okay. And how I'm going to exchange the information? Suppose if I just say Gmail. So if I use Gmail browser or Gmail website, so I can able to send the different format of the files. I'll open the web browser. I go to URL, that is HTTP or HTTPS. So we go to URL and we will open the page, and there what we want, we will search. And if you want to send the documents, we use Gmail. So like this, that is one example I can say. Okay. So here also, I want to send the information. So sender is sending the information and receiver is going to be received. Suppose here, let me tell, I am Yashoda here and you are Kadar there. You are Kadar. So I and you are communicating. How we are communicating? Over the internet, correct?
Yes.
Over the internet. So the communication, how it is happen, it will process with OSI model. This communication is crossing this OSI model. That means, so here we have 7 layers in OSI model. So one is application layer. Application, let me write down here. My pen is not working here properly. Okay.
Okay. No,
So here we have application layer. This is the 7th layer. This is 7th layer. And the 6th layer is presentation layer. And 5th layer is session layer. 4th layer is transport layer. 3rd layer is network layer. And 2nd layer is data link layer. And the 1st layer is physical layer. Okay. So these are the layers. I just draw here. So here it is connected over the internet. So here he is a sender, he is a receiver. So here we have 7 layers. This side also. So here, this is the 7 layer. Whenever the sender is sending, so first he'll open with the application layer, and then it moves on to the presentation layer, then session layer, transport layer, network layer, data link layer, physical layer. So in between here, so we have a connection here. So here, this is the physical layer belongs to the actual connection. This is a transmission medium. I can say this is a transmission medium. Transmission medium. So this transmission medium, it can be wired or wireless. It can be wired or wireless. Okay. So here in application layer, the data is called data only. So I can say that is PDU, protocol data unit. PDU stands for protocol data unit. Okay. Are you following?
Yeah, I'm with you. I'm listening to you.
Yeah. So here also the same thing. In application layer also, data is called same thing. And in session layer also, data is called PDU only. Whereas in transport layer, the data is called as segment. Data is called as segments. And in network layer, data is called as packets. In data link layer, data is called as frames. And in physical layer, data is called as bits. Can I ask you the question now?
Yep.
What data is called in transport layer?
What data?
What data is called in transport layer?
This is the one left side on the network layer.
This one. Segments.
Segments and packages and frames.
Yeah. Transport layer called segments. Network layer, data called as packets. Data link layer, data is called as frames. Network layer, data is called as bits. Here also. Clear? This part is clear?
The left side?
Yeah, I'll go with the next slide.
Oh, okay, yeah. So my question is, these two connection for, can you come back? Yeah, sender and the receiver.
Yeah.
So you say they can use wired or wireless?
Wire or wireless.
So are they close to like next house to me, or like it's two city like you are where you stay?
Yeah, you are asking that I'm staying in 2 different cities.
Okay, okay.
Wireless is not possible. Direct connection it will not. See
Yes.
how the network it will be in. So here you can just see internetwork. See, this is how you can see these images. We have multiple switches, we have multiple routers. The data need to be crossed. Suppose this is a source and this is a destination. What I have written here, sender and receiver. I call this as source. The sender is called as source. The receiver is called as destination. Data need to be crossed from this to this level means it has to follow some protocol. So
Okay.
that protocol is who is going to manage or how the data is going to be sent through the OSI model. So it is a conceptual model we call. That means it is a theoretical model. And
Okay.
at the back end for the devices, so it will be understandable. Clear?
Yep.
Okay. So here, let me read this. To address the problem of network increasing in size and in number, the International Organization for Standardization. So here ISO is called as International Organization for Standardization is the company, research company, so who has introduced the OSI model. Many network schemes and recognized that there was need to create a network model. So the reason why they have created a model, I have explained you. Why they have created a reference network model? To
What's that?
exchange
Exchanging
the information from
protocol.
one manufacturer device to other manufacturer devices. So in
IMD, yep.
1960s and 1970s, so this was not
1984.
happening. Suppose if I want to exchange the information, that means the company needs to be utilized. They have to purchase with the same products. That means HP products here also they have to go with the
Okay.
HP products.
Okay.
So that was not the easy solution, right? So we
Yes.
have we were moving forward and we are not able to depend on one manufacturing company. So that was the problem. So what they have decided? They decided that they have to create a network model. So that network model, which is the first model? Which is the first model they have created?
Yes.
Which is the first model they have created?
HP.
TCP/IP model. This one.
Okay.
TCP/IP model was the first model they have introduced. This one.
Okay.
Okay. So then they have. So this was for troubleshooting, for monitoring. There was some issues on this model. So they have introduced with the OSI model, enhanced version, by keeping reference of TCP/IP model. This part is clear?
Yep. Although it's new for me, but yeah, I'm catching up.
If you are not able to understand, I'll repeat it again. No worries.
Okay. Okay.
You can ask me.
Okay.
Okay. So this would help network builders implement networks that could communicate and work together. So what is the reason of network model? It helps for the network to implement the networks and also could able to communicate, and also it will makes easy to work together. Okay. So they have released OSI reference model in the year 1984. Yeah. So don't get confused. ISO is nothing but International Organization for Standardization. OSI means Open System Interconnection. So IOS means Inter-Network Operating System. So this is the expansion of the each one, ISO, OSI, and IOS. Okay. So here ISO can be also we use International Standard Organization. To avoid confusion, people will start to call ISO as International Standard Organization. This as well as this, both are same. Okay.
Okay.
So now the OSI reference model. So you can see there are how many layers in OSI reference model? How many layers? 7 layers.
7 layers.
Which are the physical
Application.
layer? From down to up, we will say. The thing why we have written application is the first means here I have shown you. See how data is sending. The sender is first go for the application. That is your web browser. You open some application and you use that browser and he sends. From here it will start from upper layer. This 765 we call upper layer. 3 to 1 is called lower layers. Okay.
Okay.
Here also, these three are upper layer, these three are lower layer, transport layer is the middle layer. Clear?
Okay.
Okay. So now how data will send? Data will go from lower layer to upper layer or upper layer to lower layer?
Upper.
Upper layer to lower layer. How
Low.
data get flow? Upper layer to lower
Low.
layer. How at the receiver end? It receives data from lower layer to upper layer. Clear?
Yep.
Clear?
Yeah.
Okay. So at the source end, it sends data get flow from upper layer to the lower layer. At the destination side, data get receives from lower layer to the upper layer.
Upper layer.
That is why, so we go in this order: application, presentation, but number you can see. Which is the first layer? Which is the first layer? Physical layer. Layer 1 is physical, layer 2 is data link, layer 3 is network, layer 4 is transport, layer 5 is session, layer 6 is presentation, layer 7 is application. You have to by heart this one. Can you
this slide is sender, right?
Yeah, you want send slides?
No, I mean this one, as my understanding, is a sender.
Yeah.
Not receiver. Okay.
Yeah, sender side this one.
Yep.
You have to memorize this one. You have to by heart this one. Can you do this? You have to remember this, okay?
Okay.
Here you can see application layer, presentation, and session are called as upper layers. So the data flow layers also, all four, below all four are called data flow layers or lower layers. Okay? Clear?
Yep.
And here, what is application layer? So this layer is dealing with the network applications like your email or the web browsers. Okay. These layers are dealing with your network applications. It may email or it may be any web browser. My web browser here, I'm using Chrome. Correct. I can use even Microsoft Edge, or I can go with Oracle. Okay. Or I can go with Internet Explorer. Any of the web browser I can use. So that belongs to the application layer. Okay. Each of the layer have PDU. I have told you. PDU means protocol data unit. So what do you mean by protocol data unit? See here. PDU is called
data unit.
In networking, protocol data unit is the basic unit of exchange entities that communicating using a specified networking protocol. Okay.
Yep.
PDU is called a, so they will ask you the question, what PDU is called in network layer? So what should my answer? What PDU is called in network layer?
Packages.
Packets. What PDU is called in transport layer?
Segments.
What PDU is called in data link layer?
Premise.
On physical layer?
Is that digits?
Bits.
Oh, bits or BI. Okay.
Binary digits, BITS.
Okay.
What PDU is called in application layer? PDU only. Okay. Data only or data only. On all the first three layers, PDU is PDU only. There is no any changes going to be happen for the data in these three layers. It will recognize for which browser it has to use, on which format it has to use, and the session needs to be established. These are the three things which is going to be done by these upper layers. And the actual data gets flow from the below four layers. Transport layer, network layer, data link layer, and the physical layer. Okay. Getting confused?
No. It's my first day, you know, kind of new.
Yeah, it's new for you.
Yeah.
So next is presentation layer. So presenting means, what is the actual common word, common meaning of presentation? What is the meaning of presentation?
Presentation is this layer is responsibility for presenting data.
Yeah. So I want to say you, that means, see, I have Excel sheet. You have used Microsoft Excel. Have you used a Microsoft Excel?
Yeah, I do. I did. Actually, I
Microsoft
use
Word. Microsoft Word.
Excel.
Excel, Word, PowerPoint, all this have you used?
Yeah, I did. Yep.
Yeah. Have you know these photos? See here, if I just go here, right click here, go to properties. Okay, I don't want to go for property. Here also it's showing .png. Can you see here?
Yes. BNG.
.ppt
Yep.
and .pdf.
Yep. The BDF. Yeah, I used that.
Yeah, different .doc.
Yes.
The format. And here, if I just open any of the WordPad, so here the programming language or the language which it is using, we have like EBCDIC, we have ASCII. These are the languages we use for this one. Correct?
Okay.
You know
Okay.
about that EBCDIC? I'll just type it here. See here, ASCII or EBCDIC. So these are the languages we have. Unicode.
Okay.
EBCDIC means extended binary code. And here ASCII means American Standard Code for Information Interchange. So this is a 7-bit character. This is a 8-bit character.
Okay.
Okay. So we have, suppose, let me tell, I am composing my Gmail. Okay. I want to attach some file. This file, so here, any of the file. Okay. Let me take here any of the file. This file, the language here, it is used ASCII. Okay.
Okay.
Here it is used ASCII. Let's assume in that way. I'm sending you that file, which is the language they have used in ASCII language or Unicode language, I can say. That is the language. Why at the end of, at your end, you may using EBCDIC. It has designed with EBCDIC.
Okay.
So now the thing is, have you ever noticed whenever we are downloading any of the files or any of the documents, so it will take time to open. Why? Because the font size, the font style, everything need to be what sender has sent. Suppose the example which I have shown here, I am using ASCII. Let me say here, I am using with ASCII. Okay, and you are using with EBCDIC. So now this, I'm using some font size, some font color, that and all. Everything need to be open in that format only. But here, this is 7-bit code. This is 8-bit code. So it has to get compatible from sender to the receiver, correct?
Yep.
It has to be compatible from sender to the receiver. Compatibility from sender to the receiver. So
Receiver.
presentation layer decides how data need to be represented. This layer is responsible for presenting the data in the required format, which may include like code formatting. I told you, code formatting, like it can be ASCII or it can be EBCDIC, anything. And also presentation layer involves in presenting the data. That means it encrypts the data. What do you mean by encrypting? What do you mean by encrypting?
Everything, I don't know.
Encrypting, no? Don't know?
Yeah, I don't know.
Encrypting is nothing but readable knowledge to unreadable knowledge. Readable format to unreadable format.
Okay.
What is encrypting?
Unreadable format data.
Yeah. Let here. Encryption and decryption. Encryption is a process by which a readable message is converted to a unreadable form to prevent unauthorized parties from reading it. Why it is necessary? Suppose I want to send you the mail. So I am just attaching some file here and I am sending you. So presentation layer, what it will do? So whatever the data it is there inside that file, it will encrypt that file and it will send to you. At the receiver end, it will decrypt. At the receiver hand, it will decrypt. So here, let me take. See here, the presentation layer, here what it will do? It do code formatting and also encrypting and also compression. At the receiver end, it will decrypt. It will decrypt and it will decompress. Clear?
Yep.
Clear this part?
Yes.
So in between, from sender to receiver, if any unauthorized person is trying to access that information, so they should not able to access to the document and it should be not in the readable format to avoid such like hacking and all. If it happens, it should be not in the readable format. So that is the responsibility of the presentation layer.
Okay.
Clear?
Yeah.
Yeah. And here compression also. You know what is compression?
No.
Compression means, suppose let me tell I have 1 GB of data. I have 1 GB of data. This 1 GB of data, it's not possible. It takes much time to send this 1 GB of data over the internet, correct?
Yep.
Yeah. So this data will compressed. Compressment, it will just make it compressing is congested. The data will be kept in congested. So instead of 1 GB, it will show you, if we after compression, it may show you like 512 MB, like anything. So we have that option on the documents as well. We have that option. If we are using NTFS file system, if we go here, suppose you just click here, go for properties, you can see here, compress contents to save disk space. Can you see here, compress or encrypt attributes?
So comparison, it shows you how much gigabyte or GB you have.
Yeah, suppose if I just go for any of the folder here, let me take here, I have some, okay, I go with this folder, go to properties. So what is the size of this folder? 472. It's very less, 472 MB. It's very less. I'll go with other one. Okay, here I'll go with other one. Okay, I just go with this one. Go to properties. What is the size of?
Wow, 11.9 GB.
119 GB, correct?
Yep.
If I go here, if I compress it, it will less the amount of disk space. It will compress the data and it will send. It is easier for sending and receiving. It will be easier if we compress the file. So you want me to show here? Let me type it here. See, what is compression and decompression? Compression reduces the size of application or document for storage or transmission. Okay. Compressed files are smaller and also helps you to download faster and easier to transport. So at the receiver end, it will decompress. Okay. What is the job? Which layer's job is that compression? The job of the presentation layer is encryption and compression. At the receiver end, can I read? If it is encrypt, I can't read. So it has to decrypt and it has to decompress it. So it will take that one. Encryption, decryption, compression and decompression. Presentation layer. Clear?
Yep.
Okay. So next we have session layer. So session layer. This layer establishes, manages and terminates session between two communicating hosts. So suppose, see here, I and you are communicating. Why? Because our session is open. For example, if I just say a telephone, I wanted to call you. So what I will do, I'll dial your number and exchange office will take my call and it will retrieve to your number, correct?
Yep.
There is a network in between me and you. So here, whenever I started to call you, so the session has to be established first. How the session is going to be established? By using the mobile number, we are establishing the session. While we are talking, now I and you are talking, we are in the communication, correct? The session is managing. And if I want to end the session, so that will be terminated. For example, one more example I'll show you. If I open this one, where to send it up? Okay. So now I have one tab here. I can open new tab, correct? Let me open a new tab. Okay, I have opened new tab. Now I want to go for facebook.com. I just type here Facebook login. Facebook login. I just go. Now, if I just log into Facebook, I'm just going to that website right now. Okay. I log into Facebook. So what here it is telling? So it's already logged in. So here, if I just log out, I just come here and I will log out.
Okay.
I log out. So now I want to provide the username and the password and I have to log in. Correct?
Yep.
So that
section is, yeah,
it is establishing the session with the Facebook server. While I am in the session, it will manage that session. I want to log out, it terminates my session. The same thing here also. In Gmail also, what we will do, if it is signed out, so I want to sign in, or let me go here. I want to add another account. So now I want to provide my Gmail and I have to go for next. And then I have to provide the password. I have to go for next. So this is where it will retrieve. It will retrieve to my Gmail server. Correct?
Yep.
Yeah. So that is called session establishing, session
establishing and section can end.
Manages and session terminates between two communicating hosts. That means it creates a virtual circuit. Okay. And also coordinates communication between system and organize their communication by offering three different modes.
Let me shut down the door, please. 1 second. Huh?
Which
please.
one?
I want to close the door. 1 second, yes.
Yeah.
Thank you.
Hello, sir. Idira.
ಹೌದು ಮೇಡಮ್ ಕೇಳ್ದೆ ಹೆಂಗಿದ್ದೀರಾ ಮೇಡಮ್ 3 weeks ಹೆಂಗ್ ಓದಿಸ್ಬೇಕು ಅರ್ಥನೇ ಆಗೋದು
ಡೀಪಲ್ಲಿ ಹೇಳ್ಬೇಕು ಒಂದೊಂದು ಪಾಯಿಂಟ್ ಬಿಡಿಸಿ
ಬರೀ OSI ಒಂದು ಮಾಡಿ ಮುಗಿಸ್ಬಿಡಿ ಒಂದು another 20-30 minutes ಅಲ್ಲಿ
okay so here it creates a virtual circuits and also it works on 3 modes. Session layer works on 3 modes, that is simplex, half duplex and full duplex. So what is simplex? Can you tell me the example for simplex?
Simplex.
Walkie-talkie.
Walkie-talkie.
Sorry. walkie-talkie alla. Remote,
Okay.
TV remote.
Yep.
Can only send the signal to the TV, correct? I cannot receive back from the TV to the remote. Is it possible?
No.
No. So simplex example is TV remote, I can see. Okay. And
Okay.
here, half duplex. Half duplex. So I can say here walkie-talkie. Walkie-talkie, one-way communication or one-way communication, you can say. One-way communication. You know about walkie-talkie? Securities,
No.
police, they all use walkie-talkies.
Yeah.
Yeah. So if I am talking, both the person can't communicate at a time.
Yes.
Only one person can talk one time.
Yep.
One person finish, then the other person need to be continued. So that is single way, one way communication we say. So that is called as half duplex.
Okay.
Clear?
Yep. Walkie-talkie.
Yeah. So your full duplex. Full duplex is your mobile phone or telephone, whatever. Mobile or telephone or online training, online collaboration tools. Okay.
Okay.
So these are the examples. This is clear? Simplex, of
Yep.
duplex and full duplex. This is clear? So these are the three modes which suppose by session layer. Organize their communication. It can be simplex communication, or it can be half duplex communication, or it can be full duplex communication. It's supposed for all the three modes. Okay?
Okay.
Okay. So can you read this slide?
Yep. It uses only one wire pair with a digital signal running both directions on wire.
Half duplex. This is for half duplex.
Okay.
Yeah. Go ahead.
Oh, okay. It also uses the CSMA CD protocol to the help collisions. I can't even see the.
Yeah.
Right.
So
Yeah.
here half duplex. So there is one protocol or there is one technology we call CSMA CD. So CSMA stands for Carrier Sense Multiple Action. Answer CSMA multiple avoidance. Multiple. 1 second.
Carry sense multiple access collision detection.
Multiple access and collision detection. Yeah.
Okay.
So CSMA. What, sir? Collision sense, multiple access and collision detection. So this is a type of protocol which used to prevent the collision. Suppose, so let me, okay, I'll give you one example. So there is a road here. So this is just this is a road. And here, so this is a circle. And here also, this is a circle. We have road here, this way also, this way also. So all the side, how the traffic manager or traffic police manages the traffic with the help of signals, correct? With the help of signals.
Signal.
Yeah. What signals? Red, green, and amber. Red, green, and amber. So whenever he wants to send this traffic, so what he will do? He will provide green signal here. Correct? He will provide green signal. So these vehicles passes, then he allow this road, then this, then this. So one after the other, correct? So
Yep.
here also, whenever we have a different networks here, we have different networks here, different networks here, here also different network, here also different network. We have different network. So I have let me take here, we have 100 users here. We have 100 users. So here also we have some 200 users in this way. Here we have some 500 users. And here we have some 50 users. So now tell me, if all the users are sending the information at a time from all the way, what will happen? If all the
It will
vehicles
crash
are
all. Yes,
passing at the time, what will happen?
it will happen crashes.
Crash. Can I say that collision?
Yep, collision. Yeah.
Yeah. So to avoid that, we have a technique called CSMA-CD protocol to prevent collisions and to permit retransmitting if a collision does occur. So here now tell me, suppose if vehicles get collide, can that vehicle, can I put it in the good way? Suppose if it get accident or anything, it takes lot of procedures, right?
Yep.
Suppose if get accident, need to be police complaint, and if injured person is admitted, he has to recover, it takes a time, and the vehicle if get damaged, it will take a time, and we have to spend lot of money. This is the process we have to cross over. Whereas here also, if any data is collide and if data is lost, what will happen? It will allow to retransmit the data if collision occurs. So that will taken care by the CSMA-CD protocol in half duplex.
Okay.
Clear?
Yep.
Okay, next point is, if hub is attached to a switch, it must operate. Okay, this all it will explain in your network devices. I'll go again, I'll take this part in network devices. Here it will be more for you. Okay.
Okay.
Yeah. So this is one example for full duplex. So you can just see here, I have 10 or 100 Mbps for sending and receiving. So both, it will support for both the speeds, 10 Mbps and 100 Mbps. So vice versa. So sendings, there is a simultaneously, it can send the data and it can receive the data. So that is a full duplex. So here, network uses twisted pair cabling. One pair is used to carry the transmitted signal from one node to the other node. So a separate pair is used to return or receive. So here what happens in twisted pair cabling, we have a 8, suppose if I go with UTP or STP, we have 4 pairs, that is 8 wires we have. How many? Do you want me to show you that? See here, twisted pair cable. Can you see here?
Yep,
How
I can
many
see.
pairs?
1, 2, 3, 4.
4 pairs. So each pair is of 2. That means single, if I say 8 wires.
Yep.
Okay. So this is the twisted pair cable. So here, one pair is used to carry the transmitter signal. One of the pair is used to transmit the signal from one node to the other node. And another pair, another separate pair is used for the receiving signal. It is possible for signals to pass through both pairs simultaneously. So the capability of communication in both directions at once is known as a full duplex. Did you got idea?
Yep.
Okay. So here you can just see. So these are the wires. So this is one. So we have transmitting and receiving. There is a number for the we have color coding and all. In that we will explain you what is the transmitting and which of the wire is for transmitting, which are the wires for receiving. So here that 2 pairs of wires, what it has, it will allow you to send as well as receive. Okay, so that is the logic behind these wires for full duplex. Okay. Okay, Kader.
Yep, I can hear you well.
Yeah. So next we have transport layer. So this layer breaks up the data from sending host and then reassembles it in the receiver. It also used to ensure reliable data transport across the network. So what will happen whenever the data is sending from upper layer, at the transport layer, the data, suppose if I say I have, this is my data. So this is of 500 MB of data I am sending. I want to send 500 MB of data. So this data will be segmented. It will be segmented. So let me say here, I will divide into 4 segments here. So here, this is 100 MB. And here, this is 100 MB. This also 100 MB or 150 MB. And here, this is 150 MB. So my data will be segmented. It will be dividing into the segments. This is example which I'm showing you here. It's not exactly like what I have given. It will be not in that way. Okay. So before we have 3-way handshake, that and all we have. So I'll explain you that in the later on classes. So like that, it will just decide how much amount of data need to be sent from sender to the receiver. Suppose, let me say I have a 2 PC here. I have 2 PCs here. So this side, if it is able to send and receive with 10 Mbps, the other side, this is capable of send and receive 100 Mbps. So now tell me, I have the speed limit here. The send and receive is 10 Mbps. This machine sending and receiving with 100 Mbps. If this machine is sending the data with the speed of 100 Mbps and this machine is capable to receive only with the 10 Mbps. So how these two is going to exchange the information? On which speed these two machines are exchanging the information? Whether it receives or with 100 Mbps or it sends with 100 Mbps. What is this?
I think the 100 MB is bit more.
Yeah, did you understood my question?
Oh, my understanding was the 100 Mbps is more power than 10 Mbps.
Yeah, this is high speed, this is low speed.
Okay.
So which speed this 10, suppose this 100 Mbps is sending a data.
Yep.
Okay, with the speed of 100 Mbps. This machine receives with which speed? It will receive with 100 Mbps or 10 Mbps. This machine.
Okay.
What is the speed limit? He can
10.
receive only with the 10 Mbps.
10.
Okay, that means I'll make you understand more. Suppose if I just say I have big water pipe. I have big water pipe. This is a water pipe. Okay. This is a water pipe. This is big water pipe. Okay, and I will attach for this in front of this small water pipe. Small water pipe I am attaching. This is a small water pipe. Okay. So now how much amount of water can be stored here? It is a more water or less water in this pipe?
Less water.
In this pipe, more water.
It's a big, more water can come in.
Yeah. In this pipe, less water. Even though I have a big water pipe, but my exit is only less water.
Wow.
How much amount of water can come out? Is it big water or less water?
Less water.
So the same example here. He's having a capacity of sending 100 Mbps speed, but the receiver is received and he can send only with the 10 Mbps speed.
Okay.
Okay. So here also, while doing segmentation here in the transport layer, so the layer breaks up the data from sending host and then reassembles it in the receiver. At the sender end, it will divide the data into segments. At the receiver end, it will reassemble that data. Okay. And also it is used to ensure, that means reliable data. So the two major protocols we use in this transport layer, so that is TCP and UDP are the two major protocol we use here. I'll explain to you on that part in the later on classes. Okay. Which are the two protocols we use in transport layer? TCP and UDP. Which are the two protocols? Can you tell me?
What is that?
TCP and UDP.
UBT and BTA.
Are the two protocols used in transport layer. Okay. So here TCP stands for transmission control protocol, and
layer.
UDP, yeah, not layer, protocols. Okay. It is. User datagram. User datagram protocol. Okay. So this TCP is a connection oriented. Connection oriented. And here this UDP is a connectionless. Connectionless protocol. Okay. That means, see, I can give you example here. What is connection oriented and what is connectionless? Connection oriented means we are able to communicate, right? We are able to communicate. So before communication, the TCP protocol will establish a connection. The TCP protocol will try to establish a connection. That means it will set what amount of data it can be sent. Suppose if it is a 10 Mbps or 100 Mbps, it will limit, and the size, everything, it will be checked by the TCP protocol. So we call this as a reliable communication. TCP is a reliable communication. Yeah. So whereas UDP, it is a unreliable communication. Unreliable communication. So one more example I can say, suppose I am sending a mail for you with the document. So while sending a mail, if I just start to come to inbox, I will compose the mail and I will attach the document, I will send you. It will receive within a minute. Okay. If there is any delay for sending you the document, will it lose anything? Are we losing anything? No. Only it is just delay. That's it. If it is delay also, I can able to tolerate. No problem. Suppose in case in the phone call, okay, in a phone call, I'm trying to talk with you. So sometimes you could have here some disturbances or some signal loss, many things, many disturbances, distortions you can. So if there is a loss of the signal or anything, the data is going to be lost. It will affect the communication, right?
Yes.
It will affect the communication. Whereas in Gmail, will it affect the communication? No. Correct. It will not affect the communication. So
Yes.
we have two protocols to do that. One is connection oriented protocol, that is TCP, and another one is UDP. If there is any, see why again TCP is slower. This is little slow comparing to the TCP. UDP. UDP is the fastest communication. Okay, to do communication like online and all, online collaboration, or we have to connect with the calls and all, we use UDP. UDP type of protocol it will be used for fastest communication. For little slower, it use TCP communication. So TCP is a reliable communication. If there is any data is going to be lost while transmitting the data, it will resend that data. It will resend that data. In UDP, example is in phone call. If any data is lost, can I repeat? If you tell me I have not heard what you are telling, I can repeat it, but data will be not correct itself and it will be resent for you. So that is a UDP type of communication. Clear?
Yep.
Okay. And here it can be reliable or unreliable, and also the data it will be in sequencing, and the acknowledgement will be sent, and the retransmission will be sent, and the flow control. All this will be taken care by the transport layer. Okay.
Okay.
So next we have a network layer. Below 3 layers are the actual layers which it is going to work physically. That means
Hadir,
all
you're following, Hadir.
physical devices.
Yeah.
You are following, you are understanding.
Yeah, I'm with her. Yeah, I'm with her.
Yeah, you are, because you are getting bored. First day we are teaching a lot of theory.
Yeah. So.
Sir, ಇಲ್ಲಿ ಸ್ಟಾಪ್ ಮಾಡೋಣ, ನಾಳೆ ತಗೊಳ್ಳೋಣ ಇದು ಮೂರದು.
Hadir, we'll do one thing, we'll stop, we can stop the recording, madam, first.
1 second.